Okay, let's start off with something like y equals 2 to the x. So if I ever want to graph something that I have difficulty with, I just start a table of values. So I'm not going to do too many values, -1, 0, and 1. So I'm always going to write down the equation that I'm working with, and I'm always going to substitute the first x value into the equation. And that is y equals 2 to the -1 is my x value, which is a half. So I can put that in a table, and immediately I'm going to put the point on the graph at -1, 1/2. So now I'm going to test another value. Let's do 0. So again, the formula 2 to the x. Then I'm going to substitute the x value into the formula, 2 to the 0, and y equals 1. So I can put that value in the table, and then I can put that point on the graph. So now y equals 2 to the x again. This time I'm going to put 1 into the equation, 2 to the 1. 2 to the 1 is 2. I can put that value in the table, and I can put that point on the graph. Feel free to also use your graphing calculator. Now we can see that this graph is kind of going up this way. I'm just going to do a table of values in my head. So the next value in x is 2. 2 squared is 4. And as I keep going to the left, 2 to the -2 is 1 over 2 squared, which is 1 over 4, which is a quarter. And I'm going to notice that I see this pathway that goes along. Try putting in your graphing calculator and you'll see we never hit the x-axis. We go up to the right, down to the left. We have what we call a horizontal asymptote, a line that we never cross. This line, the x-axis right here, which is y equals 0. It also happens to be the number off to the right of the equation, plus the horizontal asymptote, whatever this number is. Now there isn't anything there, so it's a 0, so we have a horizontal asymptote at y equals 0. We're also going to talk about domain and range. The domain of an exponential function is x, e, r, unless it's a word problem. The range is y is going to be greater than or less than the horizontal asymptote. So our horizontal asymptote is y equals 0. We can be everything above that. So our range is y is greater than, not equal to, because we never hit 0. So we'll be asked to graph these. We'll be asked to find the horizontal asymptote. We'll be asked to find the domain and the range. Some people also ask for end behavior, so I'll just briefly touch on that. As x gets really, really, really big, y gets really, really big. As x gets really, really, really small, y gets really, really small and close to 0. And the different notation is in our notes, but different teachers are going to require different notation. Okay, so we just graphed y equals 2 to the x. Now I'm going to use a different color. So let's graph y equals 2 to the -x. Well, from transformations, if we put -x in for x, that means that that is a horizontal reflection over the y-axis. So I can simply take my points and horizontally reflect them. So if I start off with this point here and I horizontally reflect it, I get this point here. If I take my point on my y-axis and I horizontally reflect it, it stays there. I'm essentially taking all of the x values and I'm timesing them by -1. The y-intercept has an x value of 0. So timesing it by -1 will not do anything. Now if I take this point right here and horizontally reflect it, I get this one over here. If I take this point here and I horizontally reflect it, I get this point over here. If I take this point and I horizontally reflect it, I get that point there. And you can see that we've had a perfect horizontal reflection of the graph. So a couple of notes on y equals 2 to the negative x. Well, some people would say, and it's in English on the notes, that positive go up to the right. Positive exponents. Now, a negative exponent goes down to the right. Some people think about fractions, so I'm just going to do some work. I know that y equals 2 to the negative x. Now, what about y equals 1/2 to the x? Well, I know y is equal to 1/2 to the x. 1/2 is 2 to the negative 1. And then I can multiply my exponents together. Y equals 2 to the negative x. So what I know is that this graph is y equals 2 to the negative x. It's also y equals 1/2 to the positive x. So this equation and this equation are exactly the same. So be careful when people give you definitions. So either you have something like 2 to the x that goes up to the right, or 2 to the negative x, which goes down to the right, or 1/2 all to the x, which also goes down to the right. So I like to think positive exponents go up to the right, and negative exponents go down to the right, and fractional exponents go down to the right. But keep in mind, there's so many ifs, thens with the positives and the negatives. Just start to memorize the basics, and that will allow you to do more harder questions without confusion. Okay, so we just saw y equals 2 to the x, and then we saw y equals 2 to the negative x, or 1/2 to the x. And now we're going to see y equals -2 to the x. Now, we could go back to transformations and speak about where that negative came from, but that negative right there is a vertical reflection, taking all the y values and timesing them by -1. So this time, this point right here will do a vertical reflection. This point right here will do a vertical reflection. Excuse me. Vertical reflection. This point right here will do a vertical reflection. This point right here will do a vertical reflection. This point right here will do a vertical reflection. And then we start to see this shape. And that is y equals -2 to the x. So I will let you try on your own y equals -2 to the negative x. It's a horizontal and vertical reflection, which means it will look like that. Keep in mind, if you don't want to do transformations, you can simply make a table of values and do grade 9 exponent laws. Okay, so let's take a look at y equals 2 to the x minus 2. Well, I know that this is a vertical translation equal to -2, which means we're going down 2, or simply taking all the y values and subtracting 2. So this point goes here, down 2, this point goes 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 down 2, etc. Now, I spoke earlier about a horizontal asymptote. So I'm going to place the general equation of an exponential on the screen. So we know that k is up and down. It's also the horizontal asymptote, y equals k. So our k in this equation is -2, which means that I have a horizontal asymptote, a horizontal dotted line that we never cross, y equals -2. Then I can draw in my graph. We will go over the other letters in the formula one by one. So, if I have a graph of y equals 2 to the x and I make it go down 2, the horizontal asymptote shifts down 2 and the graph looks identical to the one before. Feel free to check on your graphing calculator. All right, let's see another transformation. So let's do y equals 2 to the x minus 1. Now notice the number is in the exponent. And if it's in the exponent, well, that is a horizontal translation. Remember, we do the opposite of what you see attached to the x. So that's a horizontal translation of +1, which means that that's right 1, and we're simply adding 1 to all the x values. So this point moves here, this point moves here, this point moves here, this point moves here, etc. Now, remember, the asymptote is off to the right. We have a value of +0. So I'm going to put in a horizontal dotted line that we never get close to. So on the right-hand side, I'm going to start coming down in red. And again, we're never going to hit the x-axis. So that's y equals 2 to the x minus 1, shifted 1 to the right. We have now taken a look at k, our up and down, and our horizontal asymptote, and now we just saw an example of h. Remember, we do the opposite of what you see inside the brackets. So a -1 would be to the right 1. Okay, let's do y equals 2 to the times 2 to the x. Now, this is in front. This is a vertical expansion equal to 2. That means that we're going to be taking the y values and timesing them by 2. Now, don't get confused with this 2. That is the base function. That does not affect the base function. That is our c value that tells us what the original looks like and what transformations to do. The a out in front is our a that we learned in chapter 1, doing vertical expansions of those numbers or compressions. So if I have my graph and I want to do a vertical expansion of 2, well, I'm going to be multiplying the y values by 2. This point has a y value of 2. If I multiply by 2, I get 4. This value has a y value of 1. If I multiply it by 2, I get 2. This value has a value of 1/2. If I multiply it by 2, I get 1. Now, again, our horizontal asymptote off to the right is +0. So that is the location of my horizontal asymptote. HA, y equals 0. And again, they're going to ask you for domain and range and all the other stuff. So now let's finally take a look at the difference between let me finish this graph, the difference between a vertical expansion and horizontal expansions and compressions. Okay, so we just talked about vertical, now we're going to do horizontal. So remembering, this 2 in front is just our base function. It told us what the original looked like. We're not going to do anything to that function. We're going to look at this b value of 2. So that b value, remember, is a horizontal expansion and compression. So remember, we're going to do the reciprocal. So we have a horizontal compression of 1/2, simply taking the x values and multiplying them by 1/2. So if I have an x value of 2, that means if I divide that by 2 or multiply it by 1/2, I get 1. If I have an x value of 1, I'm going to half that value to be 1/2. My y-intercept does not change. This point is here. Now again, we're plus 0, so we have a horizontal asymptote of 0, and I can graph that function through my points. So we've now seen k up and down, h left and right, a vertical compressions and expansions, and b horizontal compressions or expansions.